Here is our second linear motion example. So linear motion, something moving in a straight line. Go ahead and read through this. Whenever we're going to solve problems involving linear motion, we need to decide if we need to use the calculus relationships, meaning velocity is the derivative of position, acceleration is the derivative of acceleration with respect to time, or if we're going to use kinematic equations, the big three. Again, kinematic equations, we have to know if the acceleration is constant or not. Calculus relationships are always valid. So reading through this problem, they're giving us a function that describes the acceleration at any point in time. There's time in here. This is not constant acceleration, meaning we cannot use the big three or the kinematic equations to solve this problem. We must use the calculus relationships. So I'm going to write this down here. This acceleration function is 3t. I'm leaving out the decimal places just in terms of making the function look simple. We will consider the decimal places given when we represent our answer. But for now, I'm just simplifying it as much as I can. We are given a velocity at time equals 0. That means that's an initial velocity. It's traveling upwards, so we do need to represent that it is positive, and the value is 3 meters per second. We're trying to find a final velocity, a velocity at time is equal to 2.5 seconds. So we need an equation for the velocity. We're given an equation for the acceleration. If you look back at the test notes, those calculus relationships, we know that we can get to an equation describing a final velocity if we have initial velocity and we integrate the function describing our acceleration with respect to time. So we're integrating with time as our variable. Our limits are going to be between an initial time and a final time. So what we'll end up with here is our v initial, which we know is upward, positive, of 3 meters per second. And then we're going to integrate this function they've given us, 3t, with respect to time. Our initial time is 0 seconds. Our final time is 2.5 seconds. So we get 3. By the way, it's not necessary to write this positive 3. Not having a negative sign implies the positive. But I want to be straightforward in reminding you that we do have to consider directions every time. So the 3 is the initial velocity. The integral of 3t is going to give us 3t squared over 2. And we need to evaluate that between an initial initial time of 0 and a final time of 2.5 seconds. So this becomes 3 plus 3/2 times 2.5 squared minus 3/2 times 0 squared, which of course if you recognize the 0 plugging in, you don't actually have to write that out. When we plug in 0, that term's going to disappear. So plugging this into my calculator, let's see what we get. 2.5 squared times 3 divided by 2. Add that to 3. My calculator is telling me 12.375. I cannot express my answer that accurately though. That's where we go back to the problem and we look at the significant figures. Each numerical value given in the problem has 3 sig figs. Even this 0.00, that is 3 sig figs, which means we need to round our answer to 3 sig figs. 3 digits would take us to the 3, but we do need to consider proper rounding rules. With this being 7, that means we need to round the 3 to the 4, and our units will be meters per second. If you want to follow the units through, the initial speed was given to us in meters per second. Because of the equation telling us that this acceleration is in meters per second squared, the 3 needs to have units of meters per second cubed, so that when we multiply by time, we end up with meters per second squared. If this 3 has units of meters per second cubed, it still has meters per second cubed here after the integration. But when we plug in the time, seconds, we're also squaring it. So when we take meters per second cubed and multiply it by seconds squared, 2 of those cancel out and leave us with meters per second. So our answer is in meters per second, which is what we need when this answer represents a velocity. So the 12.4, this object is moving at 12.4 meters per second. We get a positive answer, which means it's moving in the positive direction, which means this object is still moving upwards. So it's good to make sense of your answers in terms of the sign, what direction things will be traveling in, as well as the magnitude. Make sure it makes sense. So this acceleration is always positive. This object will continually speed up. And so we see 12.4 being quite a bit bigger than 3. So that seems to be okay.